Okay, so let's see now the hands-on exercise, and I'll show you the output and how to interpret the output, etc. Again, please understand one important thing. Here, I'm not explaining the Python code. Okay, so I'm trying to give the math intuition, the fundamentals, which is very important, and the business logic, and how to connect the output to the algorithm, right? So in other courses, you will, if you're interested, just you can reach out to me. I'll share my email ID so you can learn that more deep stuff, around ML and DL, right? So ShopSware demand forecasting using LSTM. So I just briefed you what is LSTM, what is the math intuition behind LSTM. Now, this is the data set I will be using, right? So here, irrespective of my customer ID, right? So what is SKU? It's a product ID basically, right? So this is my SKU 1. 11 units got sold on 25th, 2025, July 1st, right? This is the price. So now using this data, so what I have to do is I have to predict for this SKU what could be the sale or at an overall price sale level, right? Whatever is the price. Price into units sold is nothing but my sale, right? So this is the data set I'll be using for LSTM demand forecasting. So why this is important is, okay, you can actually plan your, this is one example, sales. You can actually do for your units sold as well. Each product level you can do so that you can plan your inventory. Okay, so this is very, very powerful exercise. Okay, so predict feature product demand for a SKU. So ShopSpear can plan the inventory and reduce stockouts. We discussed about what is stockouts and all, right? And avoid overstocking. What is overstocking means? If you bring more and more stuff, products, but customers are not purchasing, then it's a loss for the business, right? So to avoid that, these are the columns we are using, and bring all the necessary libraries, right? So these min-max scalar is the way how we discuss standard scalar, right? So this is another type of transformation for a column. These are the metrics, the evaluation metrics for forecasting. LSTM, dense, dropout, you have to import these libraries, right? The function, the respective functions. Now bring the data daily sales, load daily sales data, okay, and data cleaning and date conversion. So you have to make the date available for machine to understand. So bring that to, and then SKU for forecasting. So now you are arranging the data at a SKU level. Okay, SKU 1, date 1, SKU 2, date 2, SKU 1, date 1, 2, 3, 4, 5, and so on up to 365 days, for example. Right. So like that, you're preparing the data and you're aggregating the daily demand. Right. If there are multiple rows for the same SKU, same date, we're aggregating. That means what? Suppose, I'll show you. This is very, very important. It's because you have to bring that granularity. I've explained this earlier also. So for example, if I select SKU 2 and I'm selecting one particular date, July 2nd. Okay, there's only one. Let me do one thing. It's simple. Let's sort. Now, if you see here, SKU 2024 20. I'm not getting an example to show to you. Okay, there's only one. I think it's a random fictional data. That's why usually this SKU, this date, there will be more than one transaction. Then you have to aggregate that one. So that is what actually this term refers here. Aggregate daily demand. If there are multiple rows, just bring to the average of those so that you can have only one number at a SKU for one particular date. Right. So this is a visualization, a simple plot, matplotlib. Then the promotion and demand, again visualization. Yeah, here is the story. We are preparing for LSTM. So three features we have. What is that? Units sold, past demand, promo flag, whether the promotion was active or not, selling price. Okay, so target is predict next day's units sold. So next day's units sold demand based on the past demand, you are predicting next day's units sold. So your company ShopSpear can plan the inventory, right? So scale the features. This is a numerical feature. So scale it up for forecasting min-max scalar. and the sequence, build the sequence, LSTM sequence, features, target, and look back. How many time periods you are asking machine to look back, right? So those things. So you 14 days of history and 3 features. So we are actually giving 14 days. If you want to change to 21 days, 30 days, that is to you. You can actually do trial and error method to get the best accuracy. So splitting trial and test, then you're building the model here. I'll explain what is dropout, dense, LSTM, all these things in the output, so you'll understand easily. So this is the model, then you're compiling and deploying the final model. These are few hyperparameters of LSTM, right? So then you are plotting the training and validation loss, means each and iteration, how much accuracy it is improving and how much loss it is actually model able to fall. Validation loss fall and model is learning. Then prediction on test data. So we have separated train and test data. So you make the machine learn on the train data, predict for text data, forecast for text data, and compare both and see how the numbers are actually. So then performance. So mean absolute error, root mean squared error I've explained in theory class. Absolute error means what? So basically mean absolute error, root mean square. This is simple. The interpretation is as low as the values, the model is that good. Sorry, one second. Mean absolute error is nothing but, suppose you have your y, right? 14, 24, 34, and you have actually predicted or forecasted value using your model, right? So now this is, let's say, 12, 26, 32, right? So mean absolute error is nothing but you take the error between these two. It is 14 minus 12, 2, 24 minus, so basically it's y minus y hat. 24 minus 26 is minus 2, and this is minus 2. So the absolute value of this is 2, 2, 2. So mean absolute, this is absolute. This is error. Absolute means it ignores the sign. This is my absolute error. Then take the mean absolute error. Mean of these three is 6 by 3, which is equal to 2. So the lower, the best, the model. Simple. Similarly, root mean square, RMSE, mean square error. So you have error here. Take the square of the error. Square of the error. 2 2s are 4, 2 2s are 4, 2 2s are 4. So this is mean, root mean square means you take this to 12 square root of it. So which is around 3 point something. So what you're trying to do here is I am taking the difference between the actual and forecast, and if the value is negligibly small, close to 0, then my model is predicting really well. Simple, right? Now, then the output interpretation. So we have all these values. I'll show you in the output. See, this is my data, the Excel file we just saw some time back. All right. So after the conversion, date is becoming like this, SKU level, so and so unit sold. This is my price, promo flow, yes or no, flag yes or no. So total number of records. Right now you are actually plotting using matplotlib the daily trend. So this is date, so on up to this one, units sold. You can clearly see, because see, it is a fictional data again only for learning purpose, but in reality you definitely see some significant spikes and declines in sales due to for promotions, due to some other reasons. This is a, now you see, you can compare when the promotion happened. So this is a promo days. Is the promo days the sale is high? No, this is promo days low. When you compare, so promotions are not really doing well if you look at the sales. Or you can take another way also. Promotions sale is reducing, right? You are giving it on sale, so obviously sale value will go down. So that's it. Now see, this is actually the summary, shows how our demand forecasting model is built layer by layer, right? So the input to the model in the last 14 days of data for each day, we are using business signals like, units sold, promotion flag, and price, right? So that is your first input. The first LSTM layer has 64 neurons, means memory units. It reads 14 days of data for each day and in a sequence, right? And learns demand patterns over the last 14 days. But return sequence, when you say equal to true in the code, if you notice here, return sequence, here it is, return sequence. There is the sequential compile model return sequence, this one. So return sequence true means it passes full 14-day learning sequence to the next LSTM layer. Okay, so that is important. It has to pass. Then the next one is in the output. What is that? We have dropout. So dropout layer randomly ignores some information basically during the training. So why? Basically, this prevents the model from memorizing the training data too much, unnecessary things. So if you drop out, which is not actually helping the accuracy, that is good. The second LSTM layer, it has 32. So you are reducing it to 32. You can add as many as if you want, because every time recurrence, so it learns from the past 14 days, it will pass to the next state. Then the dense layer. Dense is what 16 neurons convert the learn demand pattern into a final prediction, right? So this is actually how your LSTM model getting built and giving the output, right? So in simple terms, the first LSTM learns time pattern, second LSTM summarizes the pattern, dense layer convert that pattern into a prediction. So total parameters, and then it is giving how much time it took each step, right? So epoch is actually one combination of all the parameters is called as epoch. So, and if there is any increase in the errors here, if you see stop 0.295, 0.5 mean absolute error, right? And it should go down. See, it is coming down. If you look at here, it is 0.18 and it is 0.1801, right? So training and validation. Can't zoom this more actually. I hope this is visible. You can actually compare how the loss it is actually able to reduce during your training and your the same model you are scoring on your validation data set. Right. So that's about the building the model and checking the accuracies, the model metrics for your uh, these things, right? What you call training and test data set. So mean absolute error and root means. So technically the model is okay, but if it is 0 point something, that is more and more accurate model. The lower the value of MAE or RMSE is the good model, right? So the model prediction is off by 3 point means what? Actually it is 10, but it is predicting as 7 point something or 6.68 or something. So 7.76, right? So that is the interpretation of these two. Now, this is your actual demand, the blue line. The predicted demand is this one. The model is predicting like this. So do you think is it a good prediction? No, because it's a random data. So just for illustration only we are using, but technically if you build, it should align with your actual prediction. Then only it's a good model, right? Similarly, we are actually using the same model and forecasting for next few days, next 7 days. This is flat actually. This is also not really a good prediction, but in general, I mean, we at work we try LSTM, right? So we use it, we deploy and we use it for real-time use cases. Then definitely it will be something like this. Okay, so like this, the trend should continue. That's about forecasting. Okay, so now SKU1, SKU level prediction has been given for 7 days, and then what is the average forecast value? You can see and tell business that how to stock the respective SKUs based on the forecasting. This is, see, if the accuracy is, if you want to improve the accuracy, you have to play these parameters here, right? So this part. If you want to add another layer, you can this. You can add one more LSTM layer, one more dropout, one more, right? If you want to, you can try more and more and see if you are improving the accuracy. Okay, so this is at a high level wherein we able to run LSTM for demand forecasting and helping business to identify the stocks which may fall under stock out or which may need over, which may need no need to put overstocking. This is very, very important use case. Okay, please go through the code. Bring another example from Kaggle. If you're interested, you can use the same code. It's simple and straightforward. All right. Then understand and try to forecast. Don't use this for stock market prediction and make decisions. because Indian stock market or any country stock market is completely dependent on so many external factors, right? Only taking the past numbers, predicting for the tomorrow or day after tomorrow is not at all recommended, right? So please keep that in mind and practice this one. I hope this LSTM RNN, this is a part of RNN. It's LSTM, gave clear understanding. You are able to, execute if you need to focus something like demand or sales like that. Okay, let's move to the next topic. Okay, so far we have seen how machine learning can work with numbers, right? So we went through the practical example as well, churn prediction, so customer age, order value, right? So these are all numerical columns, right? So delivery delay, then number of support tickets. So all these are numbers, numerical variables. So machine learning can easily fit here. So, but images are very different, right? A machine does not see a product image the way how we humans do, right? When we look at a shoe, right, we instantly recognize, okay, this is a shoe. The computer does not see a shoe. The computer see millions of numbers. So it's a challenge, right? So how do I convert all these numbers into understand? So this is where CNN comes in. Now we will be discussing a hands-on exercise, okay, on CNN. A CNN, convolutional neural network. It's a revolutionized computer vision, right? So the first thing here, I mean, I'll walk you through the math behind CNN, and then we will discuss the Python code at high level, and I'll show you the output, how a CNN actually helps in image classification. Okay, so what does a computer see basically? So it cannot see as a shoe, for example, right? So let's imagine we upload a product image. So the moment you upload a product image, so what is the objective here? So I want to check whether this image is, so while you are supplying, you have to upload the product image, right? So you have to make sure that the product image is in quality. The product is in quality. So we, as suppose if it's a shoe image, right? We see as a shoe, it has a shoe, right? But what computers see as a number, right? Thousands of numbers. So every image is actually made up of some pixels. So I have discussed this in our theory class as well. Right? Each pixel contains some color information. Right? You might have heard about pixels and all, right? For example, this is red is 255, right? Green is let's say 120, and blue is some 80. So some pixel information, some numbers. The entire image becomes one giant grid of numbers. So the first challenge is, how can the machine find meaningful patterns inside those numbers? So when it is reading the numbers, how actually it finds meaningful patterns. So imagine looking a giant newspaper written in a language you don't understand. Initially, it's just symbols, right? Eventually, you start identifying the patterns, right? That is exactly what CNN is also doing, right? First thing is convolutional layer. I'm sorry, one second. I have slide here. Just to focus on this one for a minute, right? First one, convolutional layers. So, for example, here there is a horse image, right? So you are processing this through your CNN. This is the first major component of your CNN. So think of it as a detective. Okay. So the detective does not look at the the entire image at once. Right? So instead, it scans small portions, little by little. So, or piece by piece, I could say. In our shop sphere example, instead of horse here, just imagine there is a shoe. Right? So the convolutional layer first notices what are the edges, right? What are the different curves, the shoe image. Suppose this is the shoe. Sorry, some shoe image. What are the edges? What are the curves, the lines, right? And the corners, everything. So it doesn't know it's a shoe. It simply notices the patterns, right? So imagine, suppose if you're sitting in a room in complete darkness, right? you use a flashlight. You don't see the whole room immediately. You scan each and every object in that room, like chair, table, etc. Then your brain, combines those observations, and that's exactly what the convolutional layer do or does. Right? It scans small regions of all these images and extract useful patterns. Okay, so then convolutional. Why multiple convolution layers? One convolutional layer is not enough. Think about how a child learns, right? So first they recognize the lines, then the shape, then eyes, then face, then the respective object. It's a zebra, right? So first it will identify what is the different patterns here, right? Lines, shapes, eyes, etc. Similarly, CNN also learns, first edges, then the curves, right? So then the shapes, then the object parts, then the complete objects. In the shoe example also, first it will identify the shoelace, then sole, then upper design, the entire shoe like that. Right? So that's why we have multiple convolutional layers. So during this, it happens a concept, methodology called pooling. What is pooling? So pooling is one of the smartest ideas in CNNs. So imagine you take a photograph using your mobile phone, right? The image might be very large, maybe like 4,000 pixels, 4,000 by 3,000 pixels. So processing every pixel is bit expensive, means time consuming. So imagine, so if it is a product image and you have thousands of images, it will take more and more time. So pooling is uh, a kind of process which actually flatten your fixed pixels. Simple example is if you are reading a 500-page book, okay, do you need to remember every single word? No, right? So you remember the important ideas. Similarly, pooling also, after the convolutional here, during the convolution, it will flatten, right? So I mean, like it actually try to memorize important words, and then it will send through flatten array layer. Okay, so then after convolution and pooling, it actually flattens. So it will remember only the important things and then flattens. All right. So imagine a detective, right? Collects clues. Right now he needs to prepare a report. The clues must be kind of organized. So this is what actually is happening. Whatever short or important things that has been captured through pooling and different patterns, everything is collected here and flattened. Right. Okay. So whatever features you actually identified, you just bring it to here. But then the last one, dense layer. This one. So decision making. Dense is basically a decision making layer. This you have to put in your Python code. I'll explain while we go through the code. But architecture wise, this is how actually a CNN works. So this, if you look at here, this part is feature extraction. Okay, then it is classifying through fully connected layer after flattening. Then the classification. So it is taking the input as a GUI image. It's called kernel, each part of this one. Then it is applying convolutional pooling, then flattening, then fully connected layer. Softmax is one of the activation function. So I discussed to you, right? So it don't allow you to become zero. When you are actually adding your weights in the next iteration, I discussed about gradient in theory class, right? So the same thing here. So you try to put some weights. So through multiple activation functions available in ML or DL, so you have to pick the appropriate one. So softmax works well for CNN. So then it is classifying as whether it is a dog or zebra or horse. Okay. So to conclude here, right? So first convolutional layer, so it finds edges and patterns. Pooling layer, so it keeps the important information, and then flattening, convert these features to numbers, translating kind of thing, right? Then dense layer, combine all learned patterns, whatever is learned here, then the final prediction. Okay, so in the example that we will be doing, shops here, right? So there are like about 10,000 product images they receive every day, right? So we have some sample of product images. I'll show you. So hey, human cannot inspect all of them. So why we are building CNN is to inspect that image, the product image, find the pattern, learn the shape, and detects the. I mean, it actually recognize the defects, not detects defects. So basically, if the product is actually violating any policy, right, immediately you can send it back. You can raise a flag. So to reduce time, right, and get the best product quality, product images to the consumers. Okay, so that is about at a high level CNN. Okay, primarily designed for image processing. So involving data that has a grid-like topology, such as images or videos. So image classification, you can actually classify if you have a label already trained classification, just like how we did in logistic regression, right? A decision tree. So you have a classification file, product image one, this is good or bad. Okay. Two and so on up to you have some data set to train. So, and the respective images. So machine will learn from these images whether it is a good or not. Then when you have a new image comes in, then it will predict it. Definitely, you should have past data to build the model for prediction, right? See the okay. So let's see the actual code and how to run it, and then output. And I'll discuss all these things, how to interpret as well. Okay, before we discuss the hands-on on RNN LSTM for shops peers, right? So let me spend few minutes and brief you the math intuition, because theoretically I've explained how RNN LSTM works in our previous session, right? So recurrent neural network. This is also one of the neural network dependent framework. Okay, so a recurrent. The name itself it says that recurrent. So it is actually going to reoccur, right? So let's start with a simple question. Right? So imagine I tell you saying that okay, I went to the bank. Okay, so what does bank mean? Is it a financial bank or a river bank? Right? So you don't know it, right? Now suppose if I complete the sentence in this way that I went to bank to deposit money, right? Suddenly the meaning becomes clear. Here you were not clear whether it is a river bank, because the river beach is also called as bank, right? Or a financial institution. So what happened here? You added more context here. So the later words depend on the earlier words. This is called sequence information. Okay, so in real time, time series data, text data, audio data. So these are the scenarios where you actually have to have the sequence to predict something. What do you mean by time series? So if I say my sales data, so I can actually predict my future sales or forecast my future sales based on my past. That is time series. So time dependent values. Okay. So traditional neural network look at independently the outputs. They don't remember what came before, right? So RNNs were created to solve exactly this problem. So what happened earlier? That is very important, right? Suppose if I want to predict for my future for tomorrow, what I've studied, what my experience, so I have to analyze that is the past, right? So sequentially analyze the past and get the future one. The full form of RNN is recurrent neural network. So something comes back again and again. That is the simple meaning, recurrent means, right? So unlike normal neural network, this recurring as a memory book. This is important. Memory means what? So it remembers something from the previous step, carries it forward to the next step. That is why here, if you look at here, something from the previous step carries forward to the next step. So text, speech, time series, stock price prediction, all these things, comes under as use cases for RNN. Right? So this is at a high level, what is RNN and why this is important for sequential data, especially text. Text also, right? This is example I have given you audio also, because audio, of course, you are translating that to text. So definitely you have to listen the previous words to conclude what actually has happened now, right? So the input layer, hidden layer, and the output layer. So no memory here earlier. I mean, in a typical normal neural network, if you take, right? So this is your input, and this is hidden layers, and then the output layer. But here, what is actually happening? A memory loop, right? The loop acts as a short-term memory. So every new input is processed together with that model that remembers from the previous step. So think of like reading a book. When you read page 10, right? Your understanding depends on only page 1 to 9. That is exactly. So suppose something is there on 11, you can't remember it, right? You can't recall it because you have not studied it. Similarly, RNN also exactly do the same thing. So till whatever it is actually able to read and memorize, the same it tries to do for the prediction, right? Then how this works? So let's understand the math without getting scared. Okay, don't worry about it. So suppose we have this sentence, right? You know, the customer loves the product, right? So an RNN does not read the entire sentence at once. So instead, what it does is it reads word by word. The customer then leaves the product, I mean, then loves, then the product. One word at a time. At each steps. Okay. So what is happening at each step? Input, every word it is current word, hidden state, memory of what it has seen so far, output, prediction or understanding generated from the previous step. Okay, and use it as at that step. So this hidden state is the most important one, right? The hidden state. Just think of it's a model's notebook, right? So every time it reads a new word, it updates the notebook. So similarly, RNN also works in similarly. So suppose we read a sentence like, right? I deposited my money. Say, take the same example. I deposited my money at I deposited my money at that's it. I'm not completing the statement. At this point, the notebook, already contains clues about money and the deposit. So the next word can be predicted as bank, right? So you might have seen when you were replying in Gmail, the model can confidently understand that bank means financial institute because you're saying it's money and deposit. If you don't have money and deposit, money, sorry, not deposit, money, then it is not a bank, right? So without memory also, this sometimes possible based on the words, but without memory, this word is impossible, right? So then some mathematical here. So HT equal to F of something here. So don't worry about the symbols. Don't worry about the notations here. The equation simply says that the new memory equals to the current input, right? Plus previous memory, H minus 1, previous memory, plus some learned weights combined together as a function to generate the current uh, predicted value. Okay, for example, what I know now equal to what I just saw plus what I remembered earlier. That's it. This is the equation. I've given here weights for input, hidden state, and then weights for hidden state, and this is a bias term. So activation function. So we discussed about it. So to smoothen the while it is actually calculating and moving to the next stage, right? So this RNN also has a limitation, right? So because imagine you are reading a 500-page novel, right? So on 500 page 500, someone asked who was the person introducing and pasting. So sometimes we struggle, right, as a human, but RNN also struggles because it is 500 pages. Sequence becoming longer. Older memories may fade away. This is called vanishing gradient problem. Vanishing gradient problem. So in our Shopspeare example, if I take, right, Shopspeare wants to predict tomorrow's sales, for example. So sale today depend on yesterday's sales, last week trend, the recent promotions. So RNN can remember, the most recent days. But if you ask it to remember patterns from months ago, then it is difficult to perform well for the future prediction. So that's when we got long short-term memory algorithm, LSTM. This one. So think of like LSTM as smarter RNN. That's it. The full form is a long short term. I'll write it here. It is there already. So long short term memory, right? So its purpose is simple. Remember important things for longer periods and forget unimportant things. So remember important things for longer runs. Forget unimportant things. So that is what actually humans we do naturally, right? So you remember your phone number. You don't remember what you ate like 2 months ago, right? Same LSTM tries to mimic the same behavior, right? For example, if you say that, imagine you have a very smart employee, right? So, for example, if you ask the question, should I forget? Should I store this? Should I share this now? Those generally, suppose let's say there is a secretary for you, right? A smart secretary. So every question, whenever whatever you are saying that, the secretary will ask me, should I forget this? Should I store this? Should I share this now? So those three questions are exactly the three gates in LSTM. So forget which one needs to be forget, okay, which one needs to be stored, which one needs to be shared to the next state, which you forget long short term memory, right? So the long one store, short term which is unimportant, long or short, in unimportant you forget, important ones store and share to the next state, right? So here it introduced this concept called gates. So what is gates here? To control the flow of information. So to capture the long-term dependencies. So there are three basically. So one is forget gate, input gate and output gate. So forget gate decides what information is no longer useful. Example, customer purchased a product 5 years ago. For predicting today's behavior, that information may not matter much. The forget gate may discard it, right? So similarly, if you come to input gate, so decide which new information stores, right? So example, let customer bought 10 products this week. So this is valuable information. So store it. So cell state is basically the memory. So cell state is the long-term memory storage. Think of it as a notebook throughout the journey. Important information stays here, so in cell state. Okay, this is the cell state, right? Then unimportant information gets removed. Then finally, the output gate. So basically, it decides what information should be used right now. Maybe the model remembers hundreds of facts. Not all are needed for today's prediction, right? The output gate selects the relevant ones. Okay, so simple. Again, don't worry about the equations. Each equation is simply, calculating one gate. One equation decides forget. One equation decides storage. One equation decides the show. Right? The final equation updates all the memory. That's it. Right? So let's come to the Shopspeare example that I'll be discussing in a while. Right? So Shopspeare sells, let's say, some product. Let's say winter jackets. The winter jackets. So December sales depend heavily on November demand, weather trends, holiday season, and promotions, right? So an LSTM can remember these historical patterns, those historical patterns. When January arrives, it can predict demand much better than a RN because the short-term memory, long short-term memory logic, right? So this is extremely popular for your demand forecasting, stock prediction, customer behavior prediction, and supply chain planning, right? That's it. So, to just summarize, right, RNN gave neural network memory. That's it. LSTM gave the selective memory. This is the difference between these. That's why LSTM became the workshop more popular in works in organizations, right? Of time series forecasting, text prediction, etc. Okay. So let me show you the Python code and I'll explain the output, how to interpret from the LSTM. Okay, so let's see the Python code and discuss about the output as well. I'll discuss what are the key things that you should know for CNN. Okay, so yeah, this is also kind of randomly generated based on GPT. I have given prompt to generate these images. Okay, so because in reality, you get actual data, but to practice, this is the biggest problem with CNN. To practice, you can use your own pictures. Suppose if you want to classify person one, person two, etc. So that up to you, different images of one person and classify, or you can actually use some examples, very few examples you find in for CNN. right? So that's why I've randomly generated using some prompt. Okay. So this is in the same folder, the data folder, you have all these things. So product images you have, let's say this is 1, 2, and so on up to. If you notice here, the name itself, it says it is damaged product. This is cleaned. This is wrong background, watermark is there. So clean product. So what is happening here? Already you have product images in the previous from the previous past history maybe, where manually human identified, imagine there was no CNN, so human identified saying that okay, this sort of image is clean, this is not, wrong background, watermark exists, and the blurry, for example, damaged product. So classification is done already. So you take the past classified data, train your model. So tomorrow when you have a new product image uploaded by the seller, immediately you run this model, it scores whether it is a good quality product image or not. Simple. Okay, this is one use case I'll be discussing. This is a very, very common use case in companies like, e-commerce platforms, right? So apart from this, you also have, so you also have in your data folder, product image labels. Right? So this is basically the image. This we discussed during our data discussion as well. So product image 1, 2, 3, and so on up to what is the label. So machine will understand, okay, this is the image and this is clean, right? If I select the other options here, there are few wrong background, there are few damaged, there are few wrong blurry, right? For example, this 106 product image, it's a blurry image. Okay, so it learns patterns and memorize it. Okay, what is a blurry image look like? Right? This is just for illustration purpose only, and it's a fictional data. But in reality, you have to train thousands of images to get an accurate model. Okay. Come back here. This is the folder you have product images. Now come to Python. So TensorFlow is one of the framework, a kind of library or an architecture wherein it has all the deep learning methodologies, or I could say functions. So you have to install TensorFlow before you run this code. Okay. So use case we discussed product image quality classification. So you're classifying whether the product image is good in quality or blurry or etc. Right. So clean, blurry, damaged, wrong background, policy violation. So pandas for labels, already it is stored. Pandas as a data frame, you extract that and use it for your classification model. TensorFlow, Keras is again on top of TensorFlow, a framework which has some additional methods, or I could say functions, to run your CNN. Okay, so import all the necessary libraries, Scalearn and TensorFlow, etc. So I'll discuss what is convolutional 2D, conv2D, max pooling, flatten, tens, dropout, normalization, all these things I'll discuss. Okay, so you have to bring your Adam. Adam is one of the optimization technique. Okay, for Keras, TensorFlow.keras optimizers. This you have to bring. Now, set base path first. So whichever folder you are actually using to store all your information, right? So update that path here. This is important. So please update your data. Okay. Otherwise, you see some error here. So wherever which folder you have all those things, so mention there. Then you load the image file first, right? So then also the CSV file to map it, okay, which image is actually clean versus not. Here also we have to bring some standardization to the column file. So file name label, right? So file name is label is whether it is a blurry, etc. Label columns you are actually giving into quality label, image label, category, and then path. So you're preparing data frame for Keras to run, or TensorFlow.keras to run. Here it comes for training and validation. So you're actually splitting into training data set, 80% train and 20% test data set. So these are all basic things, you can go through it. It's very simple and straightforward. All right, now you are actually creating image generator. Okay, image data generator reads an image file and converts that into a numeric arrays. Okay, so for training data, we need some small augmentations, right? Like rotation and zooming. These. So this helps your CNN becomes more robust. Okay, for validation, we can actually rescale the pixel values, but yeah, for training data set, it's good to use image data generator. Then you have visualize sample training images. Before training, always inspect a few images. If you want to see in the output, I'll show you what actually it is. Now this is your simple CNN model. Okay, so you have to start any deep learning. You have to start with sequential, means you are actually asking machine to run through this sequence, combine all these things, then run the output. Okay, so Conv 2D batch normalization, then flatten and dense. I'll explain this in a minute. You know, when I show output, you can easily relate. Then you are compiling the model, running the output. Is early stopping or hyperparameters. I'm not getting much deeper into the CNN, so I'll be putting a different course altogether, core ML part. But my objective here is the use case. So my intention is for you to bring an understanding, I mean, to a level of understanding where you can think of whether CNN works in a situation or not and how to run it at a high level, right? So this is the model you trained. Then you compare the output. This is what actually. So let's discuss the output. So this is also, to be honest, I have given detailed instructions like step by step. And then I, generated this code, using Claude, right? So it's easy for you because you should, of course, I know Python. I worked on Python, so I can easily understand whether this is a wrong or not. But for you, focus on learning basic Python first, then you use prompt-based coding. Okay. So sorry, yeah. So you see here, these are the few images it is actually saying, showing to you. Then the classification, total cleaner 133 images, damaged 34, wrong background 34. This is from trained data set, watermark 23. So 200 images are there. Validation we have 50. So total 250 images are there. So we can't train more than that because it's if you need to train hundreds or thousands of images, you definitely need a cloud-based processing unit, right? GPUs, etc. Right? In your personal machine, if it is less than 1 TB, it's difficult to run such process such images. Right? Now it is showing for you to just to see what are the wrong background, what are the clean one, damaged one, etc. Right? So now see what it is happening here is. So the keras basically is how the image travels through the CNN model layer by layer. We started with a 126 by 120, sorry, 128 by 128 color image. The first convolutional layer, this one, right, scans the image and creates 32 features. 32 feature maps basically. So these feature maps may capture simple patterns like edges, corners, colors, and textures. Right? After that, the max pooling, basically this one, right? Max pooling reduces this image to 126, 126 to 63, 63. In simple terms, this pooling, max pooling 2D is a pooling keeps the important visual information and remove the unnecessary detail so the model becomes faster and lighter, right? Then the second convolution here, this is again a convolutional TD, right? So this actually learns 64 patterns. They're slightly more complex than the earlier ones. Maybe combination of edges, combination of curves, right? And again pooling. Again pooling, this reduces the size to 30, 30. So 126 to 61, 61 to 30. Then the third convolution there. So it actually learns 128 patterns. Right? At this stage, the model may start learning higher level image features like the blurry region, the watermark region, right? Damaged areas, etc. Then the flatten converts the 1414, so reduced or pooled image, right? Image features into one list of 25,088 numbers. So think of it as converting all visuals clues into the format of numbers wherein final decisions can be made. Right? So then you have this dense layer. Dense with 128 neurons basically combines all the clues above what you actually machine arrived after the flattening and to make the final decision. So dropout is nothing but randomly switches of some neurons during the training. So this helps preventing the model from memorizing training images too much. Suppose if you think some images are not really required, right? So you can actually drop out, which are not helping to improve the accuracy, right? So finally, the last dense layer has five outputs. Basically, the model is what actually the five outputs we require, right? So clean, damage, wrong background, blurry, watermark. So this five classification it will be giving, right? So 0, 1, 2, 3, 4, 5. Some ordinal data, I mean, some one part of encoding it will use in the output and it gives. So that is how actually this works. The code actually what is doing here. This is the key part. Where is this? So bring your convolution, then max pooling, convolution, max pooling, convolution, max pooling, then flatten and the dense, right? So dense layer has the final output basically because we have five image classes, right? The model gives probability for actually it's not 0, 1, 2, 3, 4. Basically, it's a probability that that particular product image belongs to this particular class or not. So based on the need, you can actually convert them into labels. Okay, this is about some epochs and all, like while it is running different iterations, how much time it took, and if there is any loss. Loss means what? Accuracy, and loss is basically accuracy is what 0.2. This is bit low. Again, this is a fictional data, so you have to check for the loss and all. If you want to practice more CNN, if you want to know, I'll be giving a complete deep learning course as well, wherein I will explain each and every part in detail and along with the Python code. Right. For now, the objective is for you to understand the application. So when to use CNN, how to run CNN, how to read the output. Same like we discussed in the ML algorithm, we have precision, recall, etc. Confusion matrix. See, 1, 2, 3, 4, 5 classes, right? So each class actual versus predicted. Sample images. Some tips I have given, you can read them. Okay, so this is how you can store the probabilities for the classification and the model every time, even machine learning or deep learning, whatever model it is building, right? It's extracting and it is building. That model can be stored in a PKL format, PKL format. Okay, so that PKL format you can use to run a score for the new data to classify whether the product is quality in image or not. Okay. So I'll upload this also in the same folder. Please go through it and run it, practice it. So you understand, at least at a high level, you get to see the what you call the output and when to use CNN, when to not. So image classification is one example. Okay, so let's move to the next topic.